Okay, where is it? Okay. Please let me know if you can see my screen.
Yes, you can see your screen.
Okay. So, okay, hi everyone. My name is Samuel Omole. Omole, yes, let me pronounce it. Samuel Omole. Okay. First of all, thank you for the recommendation. That was pretty dope. And honestly, I was trying to focus before you brought up this Barcelona issue. So he has thrown me off balance more. So let me get myself together again. Okay, so we'll be talking about building JavaScript best practices. But I think it happened when I was trying to prepare the slides. It turns out that some of my thoughts and opinions, these are my personal opinions, where basically me dog fooding or repeating something I already had in the previous slide, right? So it turns out that a lot of the things I do recommend when it comes to the best practices when working with JavaScript, I decided that, okay, yes, I could focus on JavaScript, but I wouldn't be doing justice or I won't be fair to most people joining here because you're actually taking your time to join this. Because personally, these practices don't necessarily apply to JavaScript alone. Like if I was going to focus on JavaScript, you might leave this meeting with the knowledge of the best practices in JavaScript, but then it might be harder for you to translate it to probably other languages or other technologies. So I decided to go over kind of a broader spectrum where I focus on software engineering in general, like the best practices in software engineering. And the only way I could think about that was focusing on building resilient systems, right? Because that's the goal in the end as software engineers, as software developers, as web, mobile, whatever you do, the focus, why we do this is that eventually we build up systems that tend to affect users positively. And the only way, or one of the ways we can do that is by building a system that is resilient to that said user, basically. So that's why I kind of said, okay, let me just take up my old slide and use that. So that's why you can see the name called Building Resilient Systems or How to Write Good Documentation, because those are kind of the bedrock of the philosophy I have when working. So let's get to that. First, who am I? As I said before, my name is Samuel Omole. I am not a full stack developer because I do not technically identify as one. I do work on the back end and I do work on the front end. I do a bit of DevOps, but I do not necessarily identify as a full stack. That's my personal opinion. On my day-to-day, I work with Oozuo. It's a company here in Bangkok. We're a software development agency and we get to work with some of the kind of biggest clients here in Thailand, which is quite fun. When I'm not doing that, I'm probably writing articles, probably like currently I write for Free Code Camp and some other publications. I also on the side hustle and everything. I also work on a product called Hala Message. Coming soon. It's kind of an app for business discoveries. And me and a friend actually worked on another app called Tech Directory, which is kind of like bringing the ecosystem together on like a platform where probably beginners and both experienced developers get to showcase their work. Okay. You can find me on GitHub at Sammy820. Don't really pay too much attention to my GitHub, you know, you're just be disappointed. Like it's not anything to serious like that. You can follow me on Twitter at Ajebo Developer. You can find me there. I talk about tech related stuff and sometimes I go outside tech too, depending on what happens. So let's get to it. When I talk about building resilient systems, I generally mean, because when I talk to people, when I use the word resilient, or initially when I started and I heard the word resilient, I always thought efficient, like it should be fast, right? But then again, yes, speed is your end goal, but your focus should actually be on how reliable and how maintainable your systems are, right? Even if you're building with JavaScript, you need to work, you need to work in a way where you know that the product I'm delivering is a product that is going to be reliable to the users, and in the future I can maintain it. This is the reason I focus on that, is because even while back when I was freelancing a lot, I was this kind of person that, because I tried to figure out things fast enough, I end up coming up with a lot of hacks. So I deliver code, like I deliver like an app to a client, and then the app is basically full of hacks. And I know that, and I because I'm handing it off to them, I know that probably I wouldn't look at that code base again because I've been paid completely by the client, blah blah blah. So it's like, if 2 months later the client manages to call me and negotiates for me to maintain the code base, it's always hell for me, because I'm always angry at myself for making some certain decisions at that point in time, right? So in everything you work on, it's always good to focus on the reliability of that system, and at the same time how maintainable it is, right? There's this joke that says, write code as if the person coming after you is a serial killer that knows your address. So yeah, that's kind of the whole convention, or the whole mindset when actually working with code. So first, you actually build your system to focus on it being reliable. So if I click on a button 10 times over, it should always perform the same action, and it should always be maintainable. That means I structure my code in such a way that when a different person comes into the code base, they are able to get up to speed and add new features, and the how do I put it? The ratio of features to time to delivery of new features is kept constant. So basically, for every new feature you keep adding, there isn't any degradation in speed, because what you realize with systems that are not that maintainable is that, if, for instance, you're in a product team, you get to be that 10x developer that develops features very fast, and your PM or your CTO is happy with you. But eventually, you're leaving your teammates to the dust, because when it's time to like add new features, it now becomes slower for them, or later on, it even becomes slower for you. So after 10 features, you're adding the 11th, and then you realize that it's taking you longer and longer to add new features. And that's when you realize that, okay, maintainability should have been a consideration initially. So it's those factors you need to consider while building software. So it doesn't matter the language, it can be JavaScript, and especially JavaScript, because JavaScript is kind of tricky, and it allows you to do certain things and manipulate it in such a way that you can hack your way through a very brilliant product. And when you're trying to scale it up, and you eventually realize that, oh shit, sorry, mind my language, oh crap, you cannot actually add features easily. Okay, so I told you about reliability, maintainability, efficiency, yes, but why? So these are a few bullet points. So you have the first one: maintaining software is still the most expensive part of a company's software development lifecycle. And it's true for every company, every software-based company, because over and over again, if your app, you might think as a startup especially, you might think you're shoving in money to a product as you're building up, and you're spending a lot of money, but you eventually realize that if your product is lucky enough to be one of the successful ones, you realize that, oh shit, it's actually getting more expensive to maintain that software than to actually build it. And that's when you hear developers saying things like, let me just rewrite this thing. Like, they'll be like, okay, I've actually said it before. It's not like I'm trying to shame anyone. I've said this. I've looked at the code base, and I'm like, I tell my PM that, dude, I can rewrite this thing in half the time it to take me to keep maintaining it. And it's a lie I try to tell myself, because I'm like, it's always easier for me to rewrite it than to actually maintain the code, because the code is structured in a way that isn't maintainable, right? But then if you go ahead and make the same mistakes all over again, and you're always back to this same spot where you have to maintain the software, and it becomes expensive, right? So next step, once changes are in production, it becomes hard to fix. This one is definitely a problem I've seen over and over again, where you make certain mistakes in staging, or how do I put it? Yeah, basically, in development, you make some certain hacks, or you make some certain mistakes and you leave it up to production, right? Hopefully that it works because it works on my machine. And then it's in production and certain users are complaining. And because it's in production, it's really hard to try hacks, basically. So you can't hack your way in production. You have to be sure that what you're deploying is actually a fix and not breaking any other thing. That's where it becomes hard, right? Another point, as I said before, you do not know who will work on the code base in the future, right? So you have to always consider the future. It could be future you, it could be another person, right? So it's always a concern. Always better to spend a little more time and effort to make your code base readable. Yes, this is something I had to learn the hard way because I'm also the kind of developer that wants to get features out really, really, really fast, right? So it's how do I put it? It becomes a problem once you deliver features fast, and then you have these hacks that in your head you're like, anyone should actually read this and understand if they're as good as me, right? Some people think that way. I used to think that way personally, that if the next developer coming in or my teammate is as good as me, he should be able to figure out this function or feature that I built, right? And it turns out that it might be you later on in the future who can't figure it out because you weren't thinking the same way in the future, right? You're not thinking the same way as you used to. So it's like some of the context has left your brain, and then you can't figure out why you did certain things. So it's always best to spend, even if it's like an hour extra, or I think I used to say about 20% of the original time it takes you to build the feature. You should actually use that time to actually look at the code and revise it. A trick I usually do is once I'm done with a feature, I submit a draft pull request, and then I look at the pull request later on, right? Probably 2 hours later or the next day, I look at the pull request and see my code. And because I'm seeing it with a different set of eyes, I get to see some certain things I could make better or I could improve upon. And believe you me, I could actually find bugs in my own code base before other teammates do that. So it really helps to actually spend a little more time and effort on that. Okay. So sorry, 1 second. So in terms of best practices, I try to focus on the low-hanging. The reason I call them low-hanging principles is because they are principles that are you're obviously meant to abide by, but then it brings this nuance where you're actually working in a team and you're not sure, do I do this or do I actually trade it for something else? Because the truth is that we're all building products, we're all trying to make money, we are all trying to, if you're working in a team or you're working in a company or you're working as a freelancer, you're trying to maximize your time to money effort, right? You're not trying to spend too much time for a little amount of money. So you're trying to minimize the time in which you deliver a product as compared to the compensation you're being paid for that product. So that's why I bring out this low-hanging principles as things that are easier to follow, right? So they're easier to not easy, but easier than other principles, basically. So the first one is leave the playground soon. Oh shit, this is a typo. Leave the playground cleaner than you found it. Yeah, I'll probably edit that before we publish the slide. Leave the playground cleaner than you found it. This is kind of like a Boy Scout rule, in the sense that we've all, or maybe some of us have come across situations where we inherit a code base, because that's always the very frustrating part. You inherit a code base and you're just reading the code and you're like, damn, like what was this person thinking, right? I used to think that way too. Like you look at a code base and like, what was this developer thinking? Like, why would he do this or why would he do that? Why would he make certain decisions? And you're always frustrated and you're like, damn, like if I was the one, I wouldn't make this mistake, right? So the first step for me is rather than using your energy to complain about the code base, even though it's evidently bad, it's always best to fix what you can. Always leave it cleaner than you found it, right? If you see a function that is not clear, the least you can do is write a comment explaining what you just finally figured out. Probably it took you 2 hours to figure it out. You can leave a comment above the function and say, okay, to prevent you from going through what I went through. This is the mental model for this function. This is what it does. This is what the input expects, blah, blah, blah. So that the next person, or even you, coming back to the code base in the future, you do not need to do that whole work again, right? All you need to do is look at the comments and be like, okay, yes, I can actually figure this out. It's as simple as changing the name of a function. Probably you finally understood what that function or method does, and you realize it doesn't match the name that was given to it, or a variable. Like, you can simply rename those variables to something clearer that it's easier for people to understand easily, basically. Right? The next one is dry, which is do not repeat yourself. This one is, I like this one because it's industry standard. A lot of people have heard this one. Do not repeat yourself, do not repeat yourself. It's basically the premise that when working on an application, be it using JavaScript, Java, C#, whatever language you're using, it's that once you see yourself having to repeat something, you try to find the commonalities between them and create an abstraction, right? But there's a problem with this one because it's, if you're like me and you're just hearing about it, you might be excited about this particular principle, because I was excited about it when I first found it. And basically I went through my code base and I was looking for repetition and immediately started trying to abstract it. But it was almost immediate. I started running into issues with those abstractions because I started seeing use cases that, for instance, you have two functions that do the same thing and you abstract it. Then a new teammate comes along and says, okay, I want function B to have something else that is not quite the same as function A. But because you've created the abstraction, you're like, okay, you now add an if statement that, okay, if options dot this is equal to this, do this instead. So you basically added an if statement to handle the new case. And it keeps on happening like that. So you're basically adding if else statements, switch statements, options, lookups, blah, blah, blah. And eventually you just tell them, okay, I've made this abstraction very generic, and all you need to do is pass in an options object that does everything, right? Which is, I've done that, and it's personally not something I recommend, right? So whenever you're going to follow the principles of do not repeat yourself, always try to remember another principle called avoid hasty abstractions, AHA, right? Avoid hasty abstractions, because it's basically that saying that once you figure out that there's a repetition and you want to abstract, you have to wait and say, do I have enough use cases to create my abstraction? Have I seen this repetition enough to know what to actually abstract, so that my abstraction is not hasty enough and will require me to start adding patches to the abstracted function later on? Right. The next one is the single responsibility principle, SRP. This one is pretty widespread and industry standard, where they say your function or your feature should only do one thing, right? And it's always hard to tell when you're violating this rule, and it's not really a violation, but in real life, in the real world, what I would advise personally is that whenever you're working, whether it be a code base, a feature, a function, as simple as a function, right? Always try to limit the scope of that function to do one thing. Like when I say one thing, you can interpret that any way you want, but it should just do one thing. Because where this principle becomes important is where you want to test. If you have tests in your code base, and you definitely should, it becomes way harder to test functions or features that are doing multiple things, right? It becomes like, I've experienced that a lot of times, and that's why I also encourage testing, because I would write a function, and when I'm about to test it, I'm like, oh, I can't actually test this function. I need to separate it out so I can test two different functions as opposed to one larger function, right? So for instance, you have a function that basically takes the input and is supposed to do a calculation, right? You don't use that same function to actually append the result of the calculation back into your DOM. If you're using JavaScript, for instance, it's always best to have a separate function that does the injecting into your DOM, while you have a function that actually does the calculation itself. So you can test that function in isolation without having to worry about whether the DOM is working properly or not, right? That's why I actually always encourage the single responsibility principle, right? Because if you adopt this way of thinking early enough, as you're going further, like, and you're getting to more complex, how do I put it, paradigms, like for instance, domain-driven design, microservice architectures, service-oriented architectures, you're talking about like all those kind of things. You eventually start realizing that the fundamentals of having to think of what is a responsibility, it becomes easier for you going forward. It becomes easier for you to know what should be isolated as its own microservice or its own service, for instance, right? Or its own domain. Like those things actually connect to each other in the future. So it's always something to to always consider when working with whatever, no matter how small or how large a code base might be. The next one is comments. I don't think I need to say too much about this one because it's kind of industry knowledge that we should always comment our code as much as we can. But I personally have, this is my personal opinion. I think there is something called too much comment, right? If your comment should not be too much, basically, like you shouldn't over comment the code base. It becomes harder to read, harder to understand, right? And also, you shouldn't write, your comment shouldn't tell you what, your comment shouldn't tell the next person or even you in the future what the function or the feature does, but rather why, right? Or why you made a certain decision, or why you used this as opposed to this, or why you implemented it in this way, right? So for instance, you use the for loop, your comment can say, I use the for loop here because this is a hotspot and using map or filter causes a performance issue. Like these are certain things that you can explain why as opposed to how, because the only reason you should comment on what you're doing is if you clearly know that it's something complex, right? So for instance, you have like a regex expression that is written and it's quite long. It's always best to explain, okay, what does that regex expression actually do, as opposed to like leaving it there for everyone to figure out, right? So the next one is later equals never. And this is, if I pull you back a bit, to always better to spend a little more time and effort to make your code base readable. This is kind of related to that because I personally, excuse me. I personally always thought that, okay, I could always do it later. Probably I need to deliver this feature on time. I can actually refactor. I always use that word refactor later on. And the truth is, whenever you have the opportunity to do it, or whenever you notice something, it's always best to take as little time as possible to just refactor, even if it means adding as little as a comment or renaming a variable, something very small, right? It yields its dividends in the future, right? So the next one is the only way to make deadlines and the only way to make iterations as quick as possible is to keep your code as clean as possible at all times. Yeah. This one, I always get pushback because it's like, dude, I've actually, personally, from personal experience, I've actually done a lot of hacks and delivered and made my deadlines, right? And I've also been fast. But this quote basically says that this quote is not at a point in time, but rather throughout the life cycle of or the lifetime of a product or feature, right? So it's basically saying that if you're going to meet your deadlines at all times, whether you're at the beginning of a product or you're maintaining 1,000 lines of code or 1 million lines of code, right? The speed shouldn't change, right? The speed at which you create new features, the speed at which you iterate should still be fast, because if you keep maintaining your code base at each point in time, right? Instead of adding hacks every step of the way, trying to maintain your code base by reviewing each other's code or something like that, right? At every point in time, you realize that over time you maintain a standard, right? You maintain a standard of the quality of your system, or you maintain a standard practice, and then eventually your code base is cleaner and it becomes easier to, it becomes not easier, but it remains constant, adding new features, right? So it doesn't get slower over time. Like some people will say, when Instagram released this TikTok kind of feature, and they did it within months, and people were like, wait, you have to wonder how, as large as Instagram is, how were they able to add that feature so fast, right? If the code base was not maintainable, it's going to be way harder for them to do that without breaking other things. So important principles, and these are my opinions. That's why I put in bracket me. You have your comments, you have your documentation, peer programming, code review, testing. I already went through comments. Documentation is very important because this I didn't realize how important this is because I was mostly working as a freelancer, or I was working in a product company or an agency. So I wasn't doing a lot of things for developers, right? So I eventually started working with teams, and I wasn't working on the product directly. So basically I built things that other developers had to use in the company, for instance, right? And you realize that if you're working in open source, a lot of the time, like whatever you release might be quite good, but because your documentation is shitty or is not clear enough, you don't get the reception that you were expecting, because developers are very keen on easy documentation. As a developer, I do not have enough time to try and understand what you were thinking when you build something, but rather your documentation should be clear enough to tell me what it does, right? So it's the same thing when working in a team, whether you're using Java, especially if you're using JavaScript, because JavaScript is dynamic and it's harder to understand a whole system by looking through the code base using pure JavaScript, right? Because you definitely don't know what some certain things are expecting except you document them. So documentation is really important. You document your functions, you document your features, you document your API. If you're working on the backend, API requests. If you're working on the front end, document your components, your network requests, whatever, as much as you can, document it, right? Not necessarily because for documentation sake, but for the purpose of continuity, right? So in the future, if someone else is coming to that code base, or even you could actually see this and know, okay, yes, this is the mental model that was there initially, right? Peer programming. This is also quite important because I like, even working with Oozuo, I do a lot of peer programming here because it's always nice to actually get into the mind of other developers. And I didn't do this a lot while I was freelancing. And I think looking back now, because they say hindsight is 2020, I think I might have actually benefited more if, as a freelancer, I talked to some of my dev friends. I'm like, okay, guys, I beg, can we just work on this together? So it's as easy as that. Like if you're freelancing, you could just reach out to one of your friends that you know is doing kind of the same thing. You're like, guys, can we just work on this together? So you can see the way they think, and in the process, improve your own, the way you think also. Or you could actually now end up correcting them also, right? Or reinforcing the knowledge you already have. Code reviews. This is more of, you hardly, initially I would say you hardly do this as a freelancer, and it's always when you're working in a team that you end up doing this. But nowadays I actually advise that even as a freelancer or working in a team, you should actually try code reviews. You could review your own code. Like I've done it before, right? I submit a PR to myself and review my own code. Like it helps because if you're going to transition from freelancing into working in a full-time company, these are the things that you do need to know. You cannot get away without knowing how to review people's code without sounding condescending or sounding mean or sounding derogatory, like making all those kind of weird comments that actually put people off, right? So you need to actually know how to review your own code, and you need to actually know how to review other people's code. And that is a whole different talk on its own. Basically, I could have a whole different session for just communication as a developer, right? Because that's a soft skill that every developer needs to know. Then testing, as I mentioned before, testing is very important. It's as important, if not more important, than every other thing here, right? Because how can you guarantee your code works, right? It's like you wrote the code, but how can you guarantee it works? If you're not testing, you're basically playing, or you're basically playing odds with the user, right? You're saying that I built this, I tested it on my system. I'm not sure it will work for you, but let's give it a try, right? 50-50 chance. And then your user comes back and says it doesn't work, or user says it works. So you're always at odds with that. But if you have your, let's say you're working on the backend, for instance, and you have your integration test or your end-to-end test, and you run it through your test and it says, okay, if I hit this endpoint, I get this result, and that happens, you're quite sure that you've reduced the room for bugs to a bare minimum. So if there are going to be any other bugs, it's going to be very subtle and it's going to be one of those hard to find bugs, right? So it basically gives you the assurance that what you wrote or what you built is actually going to work when given to a user, right? Yeah, so in documentation, blah, blah, I talked about in documentation, there's detailed level design, there's high level design, database documentation, bug tracking. Those are different ways you could document. I'm going to run through this. The slides will be available later on also. That's it for me. I think I'm done.